Okay, here we've got a projectile question from Jun14. They don't draw a diagram for me, so I'm going to do that. We've got a rifle bullet being travelling a distance of 420 meters. It leaves the rifle with some speed we don't know, but we do know the angle. Now 2 degrees isn't a very big angle, but to get a decent diagram we're going to exaggerate. So this angle is 2 degrees. And that's a speed of v. So our initial velocity is going to be v resolved, and as usual the angle is with the x direction, so it's going to be the x that gets the cos, so cos of 2 degrees. It's going to be v cos of 2 degrees, v sine of 2 degrees is our launch velocity, so that's going to be the u in our SUVAT. Okay, so we've used the angle of 2 degrees. The centre of the target is at the same horizontal level as the rifle, and it hits the target at the point A, which is vertically above C. So, okay, so the centre of the target is on the same level. So C is here, but A, where it actually hits, is a little bit higher. So I've got to, firstly, I'm told it takes 1.8 seconds. I'm going to substitute a t in as 1.8 later. I've got a u. I can actually set up my SUVAT straight away because I've got a u and an a. I'm going to use s equals ut plus half a t squared. I think in this question I'm not actually going to need the v equals u plus at. It'll do me no harm to set it up if I do. I think also in this question I probably could get away with using the 1.8 as my t to begin with. So a equals 0 minus 9.8. Okay, so the classic way to do this would be to substitute in, get s in terms of this u and this a, and also in terms of t. Okay, oh, you know what, I'm going to do that. So s equals u v cos of 2 degrees, v sine of 2 degrees. Okay, that's my u times t plus a half times 0 minus 9.8 times t squared. Okay. But I think I'm going to be using t equals 1.8 throughout, okay, because I think I'm only interested in here and here. The point about putting t in is it allows you to do several parts of the question about different points on the path, which I don't think is going to be needed here. So I've got to find v given that, okay, so what happens here? Well, what I know about the point A, okay, where it lands, is I don't know how high it is yet, but I do know that at A, I do know that it's travelled the distance horizontally. This is 420 meters. So at A, okay, Sx equals 420, which equals, okay, so the x part of S is v times cos of 2 degrees times t, but t, when it arrives at A, when it hits the target, t is 1.8. So in fact the only thing I don't know in that is 1.8, so I'm going to get is v, so I'm going to get v equals 420 over 1.8 times cos of 2 degrees. And cos of 2 degrees actually is astonishingly close to 1, so I'm going to get, when I do this calculation, I'm going to get an answer of 233.5, and that's a speed, so that's meters per second. Okay, the reason why they're so insistent you explain your answer is that if you did it without the cos 2 degrees you'd get almost exactly the same answer, so they need to see you've actually included the resolving, which we have. Okay, so that was all part A. Part B, we've got to find the distance between A and C. In other words, we need to know the y coordinate when it strikes the target. Okay, so that's going to be my sy. So part B, I just need to find sy. So sy equals, okay, so it's the v sine of 2 degrees times t. So v sine of 2 degrees times t plus a half of minus 9.8 times t squared. And of course I know t is 1.8, and I now know that v equals its previous answer. So this is 233.5 times 1.8 times sine of 2 degrees minus 4.9 times, and I get minus 1.209. So that's minus 1.21. There we go. What does that minus mean? Okay, well, I assumed that A was above C, but the minus, since I'm taking the y direction obviously as positive, the minus just means that it's hitting the target below C. I was asked to find the distance between A and C. Now, a distance is a scalar. It's not a vector. The direction doesn't matter. So therefore, we have to say the distance AC equals 1.21 meters, not minus 1.21 meters. So if I forget to get rid of that minus, I'll lose a mark. And then finally, we've got to state one assumption we've made about the forces acting on the bullet. Okay, so if you just spit out your standard assumptions about model it as a particle, that one actually could stop you getting the marks even if you do the other one. The fact that it's a particle is nothing to do with the forces. What we are doing, the other standard assumption, is we are ignoring air resistance, and that is actually what we have to say about forces. So sometimes in mechanics it is just as simple as just regurgitate the right one of the things you've just learned as standard.